have started recording, and I'm going to take you to the practice quiz. So exam 1, the scores were overall very good, and after class today, if you have questions on individual problems on your test, like you got points off on number 3 and you don't understand why you got points off. I tried to make comments on there, but sometimes it's hard to understand from just a comment, and you might have further questions there. So after class, I'll stay as long as I need to answer all questions on tests. So if you haven't looked at your test result yet, make sure you look at that, make sure you understand that. During the break time, you might want to go through it in detail if you haven't already, and then be prepared to ask questions later. Alright, so let me double check that I'm not muted, and let's go to A and B in the practice quiz. Okay, I'm going to give you 30 seconds more. Okay, so on part A, I'm anticipating that this is pretty easy for everybody here. And then B, the objective is to get B isolated. Whoops, common student mistake as well, dividing by the variable. You divide by everything around the variable, and you get B equals 2. Alright, now part B has a fundamental difference than part A. On part B, the x's are strewn on both sides. And so we have to collect all the x's to one side. And to do that, well, we might say, hey, numbers are already on the right-hand side, numbers without variables, so let's put all the variables over on the left-hand side. So then I would get 5x equals negative 10 divided by 5, and x equals negative 2. Alright, so just the basics with solving equations. Let me have you do 2 more, C and D. Okay, we give you 30 seconds more. Alright, on C, I would move all the x's. So what I notice is there's 3 terms. 2 of the terms contain x. They're not on the same side of the equation, but they have to be combined together. So we use the additive property. I add whatever I want to both sides. I want to add 3x both sides. And that'll cancel these out, and it'll collect all my x terms over on the left. And then I'll get rid of the negative 4 that's attached to the x by multiplication, so I divide. And then x, negative by negative is positive. Okay, and on part D, we have 4 terms. There's no like terms that are on the same side, so we can't combine anything together until we move things to other sides. So we use a property. So I'm going to say, let's move all the x terms over to the left, because there's 6 of them over there, and there's only 1 of them over here. So moving all the x terms over to the left. Now, at the same time, we can say, all right, let's move all the non-x terms over to the right. You can do both at the same time, or you can do it one at a time. If we did all this at once, we'd get 5x, and then these x's would cancel out, equals 5, divide by 5, and it's clear that x is 1. Alright, so we had 4 problems. Give me a little feedback on where you're at with these 4 problems, and if one was more difficult than the others, give me that information as well. So everybody could type that in. Don't hit enter quite yet, but just start typing in the feedback for A through D. Okay, and then go ahead and hit enter. We're going to throw complications in. So, E is very similar, and then F is starting to get some complexity here with fractions. So I'm going to give you a little time for E and F. Okay, 30 seconds more. Alright, E, pretty similar. What we've been doing, we're going to move all the y's to the left. And then we're going to do subtract 14 from both sides. And then we'll divide both sides by 4. Negative 16 divided by 4 is 4. Okay, and for part F, when we have fractions. Alright, so I notice I have 4 terms. There are no like terms on the same side of the equation. So I'm going to treat it much like I did this one. I'm going to put the 2 terms that contain y over to the left. I'm going to subtract y from both sides. Alright, so the y's over here cancel out. But over here, we already have a complication here. 3/2 y minus y. Alright, so let me do a little timeout over here. And this is what I do sometimes when I have little subproblems. 3/2 y minus y. Alright, there's 2 ways I can do this. The coefficient in front of this y is 1, and I can turn that into a fraction, making it 1 over 1. Then the least common denominator is between 2 and 1 is 2. So I'd have 3/2 y minus 1 over 1. Oops. 1 over 1. And I'm going to be multiplying top and bottom by 2 to get the common denominator. So I have, now you can also write it like this, 3y over 2, because this y is really y over 1, so it goes with the top number, not with the bottom, minus 2y over 2. Now they have common denominators. 3y minus 2y is 1y over 2. So I could use that to come out with, this is going to be y over 2. But in actuality, I probably would not have done this. Now this timeout, I often put a little box around it to show, hey, this is kind of isolated from the rest of the problem. It was just a timeout, and I want this stuff to look like, you know, a logical flow, but with a few timeouts over here where I worked out some details. All right, now, in actuality, I probably would not have done it this way. I would have said to myself, 3/2 is the same as 1.5 y's. I'd turn it into a mixed fraction. 1.5 y's minus 1y is 1/2 of a y. And I might have done it without doing any extra work, just mentally. Because that's the power of changing it into mixed numbers at times. It can really go quick. Alright, so then, once I have this, I can add, now I have to get rid of the 1/3. See, the y, I got to get isolated. But I don't want to multiply by 2 now, because if I did, I have to multiply this term, and this term, and this term, every single term by 2 to get rid of that 2. So let's just get rid of this plus 1/3 by subtracting 1/3 from both sides. Okay. And what I will get is y over 2, these cancel out. This is going to give me, now they already have a common denominator. When you have a common denominator, you just add the numerators. -2 plus -1 is -3. thirds. Now, that reduces. That's the same as y divided by 2. Negative 3 over 3 is negative 1. Okay, now I have to get the y all by itself. I have to get rid of the 2. It's being divided, so I have to use the inverse of dividing, which is multiplying. Kind of like the opposite of dividing, it's multiplying. So that these two will cancel each other out. If you take any number like 100, divided by 2 is 50, multiplied by 2 is back to 100, these two kill each other off. So I got y equals negative 2. Alright, so where I want the feedback is on F. Let me know. Please type it up, don't hit enter quite yet. Let me know if you nailed it, or if you're still working on it. If you're still working on it, was it hard to get started, or was it a particular part of it that was more difficult? And even if you nailed it, was it useful review, or it didn't really need that review? Okay, give it another couple seconds. Go ahead and hit enter, give me your feedback. Okay. Alright, I'm going to go to Casey's question. On part B, why do we subtract 3x and not divide? Let's look back. Part B. Alright. Let's look at this again. 8x equals 3x minus 10. The question was, why do we subtract 3x from both sides instead of dividing? Well, the answer is a little complicated. We could divide if we want. Let's suppose we wanted to divide to get x by itself. We could divide by 8. But if you do that, every single term has to be divided by 8, like this. And so this x would get by itself, but then you really made it complicated and you still have another x and it's a fraction and so on. And I want to review this thing right here. Why we have to, if we divide both sides, like anything we want, like 8 is equal to 6 plus 2. Watch. If I divide by 2 and divide by 2, this won't be true anymore. This is 4 equals 3 plus, the only way this would be true is if every single term is divided by 2. And so, what we need to do as our first step here is we have two terms that are like terms, but they're on opposite sides of the equation, of the equal sign. We have to gather them together first, and then we can divide, otherwise dividing by. Now, Casey, was that addressing your question or not really?
Yeah, it was. Thank you.
Okay, good.
Um,
Yes.
one of the other students said, I believe his name was Shabbat. I apologize if I messed up his name, but he said he was completely lost. He couldn't get it.
Yeah, I think that's with F, correct?
Yeah, thanks. Yeah, I know you got my name right.
Oh, you're welcome.
All right. This is a big step up, and there was more than one comment about being lost, um, and a lot more working on it. So, yes, we need to go over more of these fraction ones, and that's one of the things we're going to accomplish today. Is we're going to be working on solving equations, and we're going to have some fractions and some decimals in these equations. So let me quickly review what went here and then give you another one to work on. All right, so what I want to point out again is F looks a lot more complicated than E, but the same principles of what we accomplished in E in the same order is what we're going to do in F. So notice there were 4 terms in E. 2 terms contained the letter Y, 2 terms did not. 4 terms in F, 2 of them contain a Y, 2 do not. First thing I did in E is I moved all the terms that contain Y to the left side by subtracting what was in the right side from both sides. And that's the same thing I'm doing in F, subtracting Y from both sides. Okay, so it started out same procedure as E. But right here you start to get the fraction thing. And 3/2, and let me just run through this again too. This is called an improper fraction, when the numerator is larger than or equal to the denominator. All right, so on an improper fraction, you have an alternate way to write it. You divide the bottom number into the top, goes in there 1 time, 2 times 1, and then there's going to be 1 left over, and the remainder goes over this. So 3/2 Y is the same as 1.5 Y. And then when you're subtracting 1.5 of something minus 1 of something, it'll give you half of that something. So that's the shortcut way that we could have done that, as well as getting common denominators for the 3/2 Y minus the 1/2 Y over here. And so eventually then we get it down to this equation, but it's still a fractional equation. But it's very similar to being at this step right here. Here, what do? We subtracted 14 from both sides. Here, what do? We subtract the middle term, because these two are like terms, but they're on opposite sides of the equation. We have to get Y by itself. We subtract 1/3. All right, now these two are like terms. They also have the same denominator. So you just add the numerators, and then it reduces. And then we got to get Y all by itself. We got to get rid of this divided by 2 by multiplying both sides by 2. All right, so here's another one so you can practice the same thing again. And similar principles apply on G. I'll give you a little while to get going. Okay, let me stop you because I only want you to go part way. And we'll look at it together. So I see 4 terms. 2 terms contain r, 2 terms do not contain r. The 2 terms that contain r are on opposite sides of the equal sign. I'm going to subtract 1/12 r from both sides. This will bring all the r terms over to the left. Now, we have a little timeout. 1/2 r minus 1/12 r. To add or subtract fractions, we need a least common denominator. And they both divide evenly into 12, so that's it. So I'm going to multiply this one by 6/6. And I'm going to get 6r. Remember, the r can move up into the top because it's the same as r over 1. 6r over 12 minus 1r, which is r over 12. And now that they have common denominators, I subtract the numerators. 6r minus 1r is 5r. Over 12. That's my timeout to handle this part. The 1/12 r is canceled out. We get to this point. Okay, now let me give you a little more time. Keep going, do the next, at least the next step, but as far as you can for a little while here. Got a whole bunch of 5/12s. Okay, so I'm going to add 5/12s to both sides. Now these have common denominators. Add the 2 numerators, 10/12s. Okay, now I could reduce this fraction at this point, but I can wait and reduce it a little bit later as well. So 5/12 r is equal to, well, let me go ahead and reduce it. Divide top by 2 and the bottom by 2. There's 5, 6. Alright, let me give you just a little tiny bit more time. From here, and get that r all by itself. Okay, 15 more seconds. Alright, so to get r by itself, I need to get rid of the 5 and the 12. 5 is being multiplied, so I need to divide by 5. The 12 is being divided, so I need to multiply by 12. But the quick way to get rid of them, don't divide both sides by 5/12ths. Because then you get what's called a complex fraction, a fraction over a fraction. You got to do copy dot flip. It takes a long time, but quicker is you multiply by the reciprocal on both sides. And the 12s cancel out, the 5s try and cancel out. You just get r. Exactly what we want. And then you could multiply these two and get 60 over 30, but it's quicker to divide right away. Divide by 6. And then r is equal to 2. 2 over 1, which is 2, and we're all set. Alright, so I want some feedback on this one. Tell me about your comfort level with this fractions. You feel like, oh, I need a lot more practice, or maybe just a little more practice, I'll have it down, or very comfortable, or very uncomfortable, still confused. Don't hit enter quite yet, but type in your feedback.
Can I ask a question?
Yes.
This is Casey. Can you explain again really quick why you multiplied it by the reciprocal?
Okay. All right. So isolate. Suppose it was just 5r equals 10. What I'm going to be doing to both sides is dividing by 5. And then I'd get my answer. Suppose it was r divided by 12 equals 2. What would I be doing to both sides? I'd multiply both sides by 12 to get my answer. So here the answer would be r equals 2. Here the answer would be r equals 24. Okay. Now this one has both of these things happening together. It's being multiplied by 5 and divided by 12. And to get rid of this 5, I'm going to have to be dividing by 5. To get rid of this 12, I'm going to have to be multiplying by 12. But instead of doing it in two separate steps like this, I can do it all in one step. And when you, because watch, if you multiply the 12 and the 5 over here, you're going to get 60 over 60. But 60 divided by 60 is 1. 1 times r is r. And in other words, all these things cancel out. Casey, does that answer your question?
Yeah, so if there was another term, say it was 5r or 5/12ths r equals 5/6 minus, say, 10, you wouldn't be able to do that same thing, correct? You would have to...
Let me write that down. Say that again. 5.
Because I'm referring back to B where we subtracted that 3x, but here you're able to multiply because there's not another term, right?
Okay, way back here. Yes.
Right.
All right. So back to here, you said if it was 5/12ths r equals 5/6 plus something else, right?
Yeah.
Like plus 1/2 or something like that?
Mm-hmm.
All right. Now, if it was this, then these two terms would have to be combined. They're like terms. That'd be our next step.
All right.
This had an r in it. then these two terms can't be combined, and we'd have to like subtract 1/2 r from both sides.
Okay, that clarifies that then for
Okay.
G.
Okay. All right. So go ahead and hit enter for your feedback on G. Let's look at that. Okay. All right, so that's it for practice quiz problems for today. And are there any questions? Could be leftover homework questions. We had 2.1 and 2.2 that we haven't gone over. Any questions for either one of those sections?
Maybe this is Randolph on 2.2, number 21.
Okay.
I think I got it, but I'm not quite sure.
All right, those are good ones to ask when you're not quite sure. And I believe on 2. One of those sections, I had not put up a spot check. And so you can upload, but you couldn't upload for a spot check. Maybe it was 2.1 or something like that, so I forgot to put the spot check. So don't worry about that. Just, it won't be part of the grade. All right, so number 21. 2.2, number 21. Okay. So, when I look at this one, I can tell right away the x is going to have to be positive. Because if x was negative, then there'd be 2 negatives on the left and only 1 negative on the right. And so, you know, it's something I can tell by just observing. Now, the procedure is I need to get this x all alone. So what do I have to get rid of to have x be all alone? I got to get rid of the negative sign and the 2. And is there a way I could get rid of both in one step? The answer is yes. Multiply both by -2. Now, the negative and the negative cancel each other out when multiplying. Multiplying by 2, dividing by 2 cancel each other out. And so you get x all by itself. Notice this parentheses, how important that was. If I didn't have this parentheses, it looked like this. That means subtracting 2, which is altogether different. It's got to have this parentheses. So it means multiplying. And then all I get is x on this side. On this side, negative divided by negative is positive. I'm going to make this into a fraction. So I notice these 2 signs kill each other off. This, divide by 2, and I'm going to get 3/2. 3 times 1 over 2 times 1, 3/2. Randolph, does that answer your question?
Yes, sir. I think that's what I got. I just.
All right, good. That confirms it.
I have another question.
Yes.
It is on homework 2.2, and it's on 54 and 72.
54 to start with.
Okay.
Now there's the fraction one. Okay, and we're going to get even some more practice on this today. So I have three terms. The 1/3 and the negative 8/21 are like terms, but they're on opposite sides of the equation. My objective is to get x all along. Move this term that doesn't contain x to the other side. 1/7 x equals, and then I'm going to have these two things to add together. Now,
Right.
I'm going to do it right here. The LCD between these two is 21. Because 3 and 21 both go into 21. So if we multiply by 7/7, we get it. So then negative 8 minus 7 is negative 15/21. Alright?
Okay.
And then I notice as soon as I have a fraction, I can reduce it. If I do this, divide by 3, divide by 3. So I'm going to get negative 5/7.
Okay.
I multiply by the reciprocal, or in this case, 7/1 is just 7. And then I probably want it over 1 over here at least. And then I can see that my answer x equals, these guys cancel, negative 5.
Okay.
Alright, and you had another one?
Yes, 72.
72, which is similar. Now I'm going to hold off on 72 because we'll come back to it if time permits.
Okay.
Because that's similar to what we're going to be doing in today's lesson.
Alright.
Alright? So I think you get more out of it. Most people get more out of it by doing it rather than just watching me do it.
Okay. Alright.
Alright, any other questions? Alright, this takes us to our break time. So we will start again. At 1:30 p.m. Anybody need to talk to me for anything? Great time to check in. Here. You need to talk to me about anything?
I have a question.
Yes.
So for one of my assignments, I only received 3 points, and I'm not too sure why.
Okay, who are you?
Jacqueline?
Jacqueline, and let's go to the grade book. Last name, Jacqueline?
Merida?
I got you. Alright. It's a good question to ask. Make sure you understand where your grades are coming from. Alright. So, I'm looking through all of yours. Um,
I think you just updated it.
I did what?
I think you just updated it.
Okay.
Because I don't see the three anymore.
You don't see it now? Okay, I did update a couple things before class.
Okay.
And that was because somebody had told me about, they had part of the assignment uploaded in the spot check and the other part in the regular part, and I hadn't thought of combining those two. And so I saw a couple other people who had done similar things, and then I realized, oh, they had the whole assignment done. That was probably the case.
Oh, okay.
Yeah, because
All
I
right.
had
Thank you about that.
You're welcome.
I had actually got the same thing she had had. It was 3 out of 7, but then I looked at my email again and it was 7 out of 7
Right,
actually.
probably the same thing had happened, yep.
Yeah.
Okay. And in the future, it will tend to be a little confusing to me if you have part of the assignment in the, uploaded in the spot check and part of it in the section. So if you could have like the complete assignment in one of those, that would be easier for me, because I forget sometimes that it could be part of it in one, part of it in the other. All right, we'll take a break here. I'm going to mute. All right, we're going to get started again. And there's only 13 of us, 13 students in class today. So there might be groups that have less than optimal size. It might be just like one person in a group. So let me give a moment for groups to check in with each other. Go ahead and type in to your group in your group chat. Just say I'm here or whatever, just a real brief comment like this. And group leader, make sure that somebody knows, the spokesman for today knows who they are. And I'm going to ask each group how many people is in their group. If I don't hear something from a group, it means nobody's here in that group today. Let me give you just another second or so for checking in. All right, group 1, how many of you are here today? Zero. Group 2, how many are here today?
2.
2. Okay. Group 3, how many of you are here today?
3.
3. Group 4, how many of you are here today? Somebody mute their mic. I'm getting some background noise. Maybe Randolph, mute your mic. Group 4, there was 4, you said?
3.
3? Okay.
Yes, sir.
Okay, group 5, how many?
4.
There's 4 of you. Okay. Let me, group 1, there's no viable group today. Group 2, I'm going to have you join with group 3. So there'll be 5 members in group 3. And there'll be only groups 3, 4, and 5 today. All right. And all right. We may make a permanent shift with these, but I'll decide next time. I'll check in again in the future. All right, so let's come back. Solving equations. And I'd mentioned this before, but it's so important that I need to put it again. A solution to an equation is a value for the variable that causes the equation to become a true statement. So if I had 3x equals 6, then x equals 2 is a solution because it makes a true statement, 6 equals 6. X equals 5 is not a solution because it makes 15 equals 6, which is a false statement. When you put it back in, if it causes a true statement, it's a solution. If it causes a false statement, it's not a solution. All right, now, A is really simple. You can look at it, state the solution. But starting with B, it gets a little complex. So, let me have you do A and B. We'll get to C in a minute. Do A and B and enter your solutions into your group chat. Put a little A and then the solution, B and then the solution. But don't enter them in quite yet. Type them up as you figure them out. But wait for my cue to hit enter into your group chat. Okay, go ahead and hit enter into your group chat for both A and B. And I'll give you a little while to process that with your group. All right, group 5. What did you get for A?
We got x equals 2 is a solution.
That's right, it makes it a true statement. 10 equals 10. What do you have for B?
Still working through it. I didn't do it yet, and there's no answers in here yet.
That's the kind of thing I was expecting. Because it doesn't work out in any kind of convenient way. Let me open the floor up. Anybody have an idea about what the solution for B is?
This is Freddie from Group 3. For B, I have two answers. 2, x equals 2 is a solution, and x equals 4 is a solution. Those are the two answers I've got.
Okay, so let's check them. So on this first one, we could check it. Does 5 times 2 equal 10? Yes, it does. We'll put a question mark above it. So let's put 2 in. If we put 2 in, we're going to get what? 6 plus 6. Does that equal 3 times 4? And that side's going to give you 12. This side's going to give you 12. It works. So I agree with you. X equals 2 is a solution. Let's try x equal 4. And we're still getting some noise. Freddie, I think it's coming from your, if you can.
Whoops, sorry about that.
For a bit, yeah. And then when x is 4, we're going to get 12 plus 6. Does that equal 3? And 4 plus 2 is 6. You get 18, and you get 18. Oh yeah, that checks. So I agree. Alright, this was unusual. We had 2 solutions. Let me open up the floor again. Does everybody agree that these are the 2 solutions and then we're done with this problem? Or does anybody disagree? Alright, I'm going to do something else here. Let's try x equals 1. If x is equal to 1, what would I get? 3 plus 6. Does that equal 3 times 3? Oh, yes, it does. I'm going to get 9 on both sides. Let's try x equals 0. I would get 6 for the left side, because 3 times 0 is 0 plus 6. On the right side, I'd get 3 times 2. Does that work? Yes, it does work. Oh my gosh. Alright, I'm going to open up the floor again. Anybody else have any ideas now? What's all the solutions of this equation? Because it wasn't just these two. These two are also solutions. Do you think there's going to be more?
Yes.
You do. Okay, and we can show that every number is a solution to this. Let me just show you. Let's do the solution process on this. And I'm going to have to insert this away. So let's take the original problem, 3x plus 6 equals 3x plus 2. And probably many of you had done this. 3x plus 6, and you multiply this out, and it equals 3x plus 6. Now, what do we notice? The left-hand side and the right-hand side are identical. Exactly the same. If you plug 100 in for x, you have to plug it into both places, and so you're going to get 306 in both places. If you plug in 1,000 for x, you got to plug it into both places. You're going to get 3,006 on both sides. No matter what number you plug in for x, you're going to get exactly the same thing on both sides because the expressions are identical. Now, from this spot right here, you could have stopped and said, oh, every number is going to be a solution. This is, when you get two things that are identical, doesn't matter what number you plug in, you're going to get the same thing on both sides. So we could have stopped here and said, solution, all real numbers. And we have an abbreviation for that. This R with double thickness on the bar. It means all real numbers. Any number you think of will cause this to be a solution. Now, let's suppose, though, that you had kept going with the solution process. You said, okay, I have 4 terms. I'm going to subtract 3x from both sides to bring all the x terms over to the left. Now what happens is all the x's drop out. Well, you get a 6. What happens over here? All the x's drop out. You get 6. All right. When all variable terms, well, let's just say when all variables. When all variables drop out of the equation, then you don't have a typical situation. We never say, solve this equation. 4 equals 8 divided by 2. We never say solve that because there's no x in it. The only equation that we say solve for is ones that have variables in it. And then the value of the variable that causes it to be a true statement is called the solution. Now, what happens here is there's no variable in it because they all dropped out. When all the variables dropped out, you will have either a statement that is always true, because other statements like 5x equals 10, that can be true or false depending on what number you plug in for x. But this one, there's no number to plug in, there's no variable. So it's either always true, you'll have either statement that is always true or always false. Okay, now I'm going to stop this one at this point. The solution is all real numbers. These were incomplete solutions. And we don't want to be listing solutions because you'd be listing them forever and still never list all of them. You want to state your solutions like this, all real numbers. All right, so now, let's go to the next problem and solve this one. Again, I'm going to have you type your answer into your group chat, but work on it individually first. Type it into your group chat only at my signal. So go ahead and work. Okay, type in your answer, and let me give you a little bit of time to process that with your group members. Okay, group 3. What do you have? What's the solution?
It seems that I've only gotten one response in so far. It is -1, x equals -1.
Let's try it. If we put -1, we're going to get -3, multiplied by 3, plus 6. Does that equal -3 plus 5? Well, -3 plus 6 is +3. -3 plus 5 is 2. And the answer is no. So -1 is not a solution. Alright, let me open this question up to anybody. Anybody have an idea? What's the solution?
I know 0 works.
0? 3 times 0 is 0. 0 plus 6 is 6. 3 times 0 is 0. Plus 5 is 5.
Never mind.
No. In fact, I claim no matter what number you put in, the left-hand side will always be 1 bigger than the right-hand side. Plug in 100 for x. The left-hand side is going to be 306. The right-hand side is going to be 305. Plug in 1,000 for x. The left side is 3,006. The right side is 3,005. Always 1 bigger, and notice these two problems we just did. The left side was 1 bigger than the right side. Because these two are almost identical, let me just show you. This side could be written as 3x plus 5 plus 1. Notice you're going to get exactly, no matter what number you put in for x, this parenthesis and this parenthesis will give you exactly the same value. But this side has a plus 1 in it and this side doesn't. So this side is always going to be 1 bigger than this side. Alright, so now let's go look at 3x plus 6 is 3x plus 5. Let's do our solution process. I would subtract 3x from both sides. And all my variables drop out. Ooh! Remember? When all the variables drop out of the equation, this is something that usually doesn't happen. But when it does, what are we left with? A statement that is either all the time true or all the time false. And does 6 equal 5? No. This is always false. Now, let's look back and compare this. When we did this one, when you subtracted 3x from both sides, we're left with a statement that's always true. What conclusion did we make when what's left over is always true? We said solution is every number, because the two sides are really identical. They were just this side was disguised to make it look a little different, but really they're both 3x plus 6. What happens when it's always false? Do we make the same conclusion and say that the solution is all real numbers?
Wouldn't you say it's no real numbers? This is Randolph.
Ah, very good. There is, instead of the solution is all real numbers, we say there is no solution. There is no solution. That's it. So, come back to this. When all the variables drop out of the equation, you will have a statement that is always true or always false. If always true, solution, all real numbers. If it's always false, no solution. Okay. So this is kind of a lot of theory here. And it just shows up in a very small percentage of the problems. Most of the time, all the letters don't drop out. But every now and then that will happen. And we have to know how to deal with that. Alright, so give me a little feedback here. Are you following? Or was this really confusing? Does it make sense or not? Type it up, but hang on for hitting enter for just a moment here. Alright, go ahead and hit enter. Give me your feedback. But hard to think of applications for it. Alright, that's a good point. Makes sense. Need practice. I see that now. Hard to think of applications for it. We're going to eventually get to where we have some more applications if we keep taking math, but I'll give you just a hint of some applications for equations that might have all solutions or no solutions. These we can usually avoid these kind of equations with no solutions and so on, because we can tell that the problem would have no solution before we even started, and so we wouldn't even make the equation. But when we get to more complex situations, which we're not ready for yet, but let me just kind of show you, tell you something. Let's say two different people have a starting salary that's different. One person makes $20,000 a year, and the other person makes $30,000 a year. Okay. Now the person who makes $20,000, the smaller amount, gets a bigger raise each year, though. So eventually, he'll catch up with the salary of the other person. And so we might say situations like, all right, when will the salaries be the same? When will that person catch up? And then we can wind up with situations like this. One person's making $20,000 a year, the other person's making $30,000 a year, and then they both get the same raise every year. They both get $2,000 a year raises every year. When will their salaries be the same? Well, that's a problem that's posed that has no solution, because they'll never be the same, because they're both getting the same raise. The one person will always be 10,000 higher than the other person. Okay, so it has no solution. And if they both had started at 30,000, and then we gave them both the same raise every year, then we'd say, what's the solution? When will their salaries be the same? And then it would be, well, their salaries are the same now and will always be the same in the future. Every number is a solution for that one as well. So that's kind of a brief glimpse of where you might see these in application. All right. So now let's go to solving more complex equations. And y'all seem to handle these pretty good in the practice quiz. B and C, I want to go all the way to C, and we don't have a ton of time left over. I want to do C and show you the process here, and D, and let's get to these more complex ones. All right, so this one. If you did this, you'd be subtracting 6 minus 5 first, and then this is a really common student error. You're not allowed to combine the 6 and the 5. Remember, that's subtraction. That's dividing these into separate terms. So this, common error. The way we'd really need to do this is, I like to see this problem like this. Subtraction is the same as adding a negative. Now we distribute this. And then negative times a positive is negative, and I can write that compactly as subtraction. Negative times negative is positive. All right. Now, at this point, another common student error is doing things like subtracting 15 from both sides, or subtracting 6 from both sides. The way we want to look at it more efficiently than that is we want to say, all right, are there any like terms that are on the same side of the equal sign? So before we move on, we notice these two are like terms, and that they're on the same side of the equal sign, so we're going to put them together. 6 and 15 is 21. We'll get this. All right, so this extra complications in these are the parentheses, the subtraction in front of the parentheses, which I handled like this with plus and negative. And then also now extra terms that are like terms that are on the same side. You need to combine them first. And then I'm going to say, all right, I need to isolate this b. I'll first isolate the term that contains the b. 1, if I had $1, I spent 21, I'd be 20 in the hole. And then I divide by negative 10. B is 2. Okay. Next problem is decimals. And let me give you all a minute to work on part D. And you can use a calculator if you need to. Okay, let me have you stop. And I'm going to show on the left-hand side, there are no like terms and there's no simplification that can be done. The 0.4x, the 0 in front of the 0.4 is optional. I could just write it as 0.4x. Same with that 0. These two I can't combine together because this has to distribute. Now, I'm not going to write plus a negative, but I'm going to treat it like it was that way. So this is going to be 0.7, and then minus, now a little timeout, 6 times negative 0.3. If I had to multiply these two things out together. What you do is you ignore the decimal. You just, if you were doing this without a calculator, 3 times 6 is 18. Positive times negative is negative. You place the decimal to the right where it normally goes, but then you count back how many places. This decimal was here, there's only one place back, so you move this one place back. So the answer is negative 1.8. So that was my little timeout. Minus 1.8. And then negative 0.3 times 2. We do the same thing. We just multiply that positive times a negative, it's negative. 3 times 2, ignore the decimal, 6. Count back how many places. There was one total place. So it's negative. So it's but negative times a negative is positive 0.6x. Now you could also just do this in your head. You'd say 0.3 doubled is 0.6. Or you could punch it out in your calculator. Now, there's no like terms over here. On this side, are there any like terms that need to be added together? Yes, these two. And another timeout, if I am going to add these two together, 0.7 minus 1.8. When you add or subtract without a calculator, you need to line up the decimal. You subtract the bigger one from the smaller one. Think of it as 1.8 minus 0.7, which is 1.1. But then the sign of the larger is negative. Okay, and then we need to get all the x terms to one side. We don't have any like terms on the same side anymore. These are not like terms, these two are not like terms. But to get all the x's on one side, I can move all the x's over to the left if I want. But I wouldn't, personally. I would move them all to the right because there's more of them on the right and I'd get a positive number over here. But let's suppose I hadn't realized that and I was just subtracting 0.6 x from both sides. Then I would get negative negative 0.2x minus 0.1 equals negative 1.1. Then I'm going to add 0.1 to both sides. Line up the decimals. Negative 0.2x equals, and when I add these down, there's going to be some cancellation. I'm just going to get negative 1. The bigger one was negative. And then I need to get rid of this coefficient. Divide by the sign as well. Oops. Negative 0.2. Alright, and then x divide, these numbers and signs all cancel out, I just get x. Negative divided by negative is positive. I punch this out of my calculator, it would come out to be 5. And if I had to do this longhand, I'd remind myself, oh yeah, 8 divided by 2 is, you put the top number in the house, the bottom number out. So that reminds me, I would do 1 divided by 0.2 is the top number goes in, the bottom number comes out. And then the way you deal with dividing with decimal, you move this one place over, 2 point into, and since you move that one over, you have to move this one over, 10. And 2 goes into 10 5 times. So that would give you the answer of 5. So that's solving equation with decimal. Your calculator can be a great big friend with this. Any questions? Alright, and this takes us down. I want to take you to, let's go to G, because we might only have time for one more. Alright, so I'm going to give everybody a minute to get started on G. Okay, let me have you stop where you are. And let's look at the total of this problem first. I can't do anything until I can get rid of these parentheses. So I'm going to take 3/4, and I have to distribute it to both. Okay, now to distribute the 3/4 times the 8x, it's one of the ones it seems kind of strange, but it actually will go a little bit easier if you do the work just in your head without writing it down. When you go 3/4 times the 8, you make 8/1. The 4 and the 8 are going to reduce. 4 is going to go into the 8 2 times. 2 times the 3 will give you 6x. Now, I could have done it like this, with a timeout, and said 3/4, oops, 3/4 times 8x. And I would have made this over 1. And then I would have said, alright, divide this by 4, divide this by 4, and then multiply them together, and I see I get 6x. But instead, I just kind of did it in my head. 4 goes into 8 2 times, 2 times 3, 6x. Okay. And then we take the 3/4 and we multiply it into the 4. And I can see my 4's are going to cancel out. I'm going to get minus 3. And then there's this minus 2 that's still left. Now let me have you practice this over here. Take the 2/5, do it in your head, reduce and multiply, and then write the two results on the right hand side. Give you a quick moment for that. Okay, so when I multiply the 2/5 times the 10, the 5 goes into the 10 twice. 2 times 2 is 4. When I take the 2/5 into the 15x, the 5 goes into the 15 3 times. 3 times 2 is 6 plus 6x, like this. Alright, so we got rid of the fractions by just distributing them in. And then these two are like terms. So we always have to put together the like terms that are on the same side of the equation first. And then we're going to go from here. I'm going to subtract 6x. And I get negative 5 equals 4. Conclusion. I'm going to open the floor to anybody. When all my variables dropped out and I got negative 5 equal 4, what conclusion do I make?
No solution.
No solution. What if it had been negative 5 equals negative 5? What would my conclusion have been? All real numbers are solutions. If you get a true statement, it's going to say every number is the solution, because these two sides would have been identical. It would have been a true statement. But since it was a false statement, it's always false. Conclusion, No solution. No solution for that problem. All right, so your homework is 2.3. That's what we've been working on. If you have questions on your exam, something that you got marked off for and you don't understand, you want to know why, you can't understand my comment on that, then hang after and talk to me. Otherwise, if there's no other questions, I'll see you all on Wednesday. All right, any questions on exams? I'll see you all Wednesday.
Have a good day, sir.
All right, you too.
I need.
Okay. Goodbye. I'm going to stop the recording.